Hi everybody, so we are in week 10 and this is a video to show you what is happening in our lab for this week. So we're going on Blackboard into week by week for the rest of the semester. Blackboard is slow today, so bear with me. Okay, and week 10. And the lab is on confidence intervals, which is the first statistic we're going to be learning as a result of all the theoretical stuff we've been doing the last couple of weeks. This is our first inferential statistic. So we're looking at the overview. We'll be working in our notebooks, and we're going to generate confidence intervals around the mean for our interval ratio variable. And then we're also going to dichotomize the variable and get a confidence interval around the proportion of that variable, and we'll work on interpreting what the confidence intervals are telling us. So our first step is to log into our studio. And here. I think I missed a letter. Okay. Same thing as always as our very first step. We want to get into our console area and make sure that we are out of swirl. Okay, and as I've mentioned before, if it doesn't even understand what you're asking it, it means it's definitely out of swirl. Otherwise, if you type by, it might say leaving swirl now, or if you're at a menu that has numbered choices, you want to select 0 to get up to the next level of menu, and then 0 again to exit swirl completely. So we're done with swirl. I'm going to minimize my console. I'm getting down to the end of last week's lab. Going to just go down a couple blank lines. Remember where I am, 866, and then back to the lab instructions. One thing to note before we copy and run the chunks, there are going to be 2 new libraries that are going to get loaded in our initial instructions. We need these to do the confidence intervals that we are going to be doing today. Okay, so let's click on this. And we're going to copy everything from line 1 down to line 62. So copy back into our studio. We're on line 866. You'll be on a different line than I am just because we have different length notebooks. Paste, and then go back up to line 866. Okay, so the first thing I'm going to do is run our library chunk, load all that information. And it gives me error messages. Those aren't relevant. Just want to make sure that the GSS 100 is loaded over here in the data. If you have a lot of things in here, you might have to scroll a little bit, but once you see GSS 100, you're in good shape. Okay, so what we're going to do first is work with the variable age. We're going to get a 95% confidence interval, a 99% confidence interval, and then a 99.9% confidence interval. Okay, so let's run the chunk. And again, ignore all these error messages. So the first thing we did was get the mean for age. And so that is right up here. The mean age in the GSS sample is 45.84. So among our GSS respondents, this descriptive statistic of the mean tells us the average age for those respondents is about 46 if we round it. Then what we have down here are our confidence intervals. And our confidence intervals are giving us information about population estimates of the parameters. So what is the mean age of our American population? You'll notice that when you get an output for a confidence interval, it gives you two rows. Okay, the first row has percentages, and so it says 2.5% and 97.5%. What do those mean? Well, if you think about a 95% confidence interval, it means that there's 5% of the curve that you're not covering. And so the curve is going to start, the interval is going to start 2.5% into the curve, and the interval is going to end 2.5% before the end of the curve. Right? So in other words, 95% is contained between the 2.5% mark on the curve and the 97.5% mark on the curve. That is not our actual interval. The actual interval is what I'm highlighting right now. So our 95% confidence interval for age is between 45.7 and 46.0 if I'm rounding. And so we're 95% confident that the mean age of Americans is between 45.7 and 46.0. The same layout appears for the 99% confidence interval and for the 99.9% confidence interval. Okay, so again, in a 99% confidence interval, you're leaving off 1% total from both ends. So on one end, you're starting in at 0.5%, and on the other end, you're ending at 99.5%. So there's 1% left off that we're not sure about. But within that 99% confidence interval, the mean age for Americans we estimate to be between 45.7 and 46.0. Now, when I rounded it, it sounded exactly the same as what we got for the 95% confidence interval. But if you look at these two intervals a little bit more closely, you will notice that the 99% confidence interval is wider. It's wider in that it starts earlier, so 45.65 comes before 45.69, and it ends later. 46.02 happens after 45.97, right? So this confidence interval, even though it rounds to be about the same, is actually slightly wider than the 95% confidence interval. And when we look at the 99.9% confidence interval, this one is even wider still. It covers the widest area under the curve, and it goes from 45.6 to 46.0. When you have a large sample size, like we do for age in our GSS data set, your confidence intervals are all going to be relatively close to each other. You won't notice a huge difference between the 95, 99, and 99.9% confidence intervals. But let me type here, as the confidence level goes up, the confidence interval becomes wider. Okay. And let me just check something. Okay, so I'm going to just put an interpretation here so we're able to talk about it. Interpretation is 95% confidence interval. We are 95% confident that the population mean age for Americans is between, and where were our numbers? 45.7 and 46.0. Always remember what it is we're looking at, and this variable is age, which we are measuring in years. So you don't have any percentages down here. This is 45.7 years and 46.0 years. So that's the interpretation. The next thing we're going to do is practice making a dichotomous variable. Many of you will have to do this for your projects. If you have a variable that is nominal or ordinal and you want to work with it with confidence intervals, we're going to have to recode it to make it into dichotomous. And I will help you with that. I just need to know what your variables are and how you want to recode them. So let's look at what we're doing here. We are creating a variable in the GSS called no child. And it is a dichotomous variable, and it says when somebody has 0 children, or less than that, which you can't really have, when somebody has 0 children, create a variable called no child that is 1. And in other words, if somebody has a child or more than 1 child, they're going to be coded as 0. So that's what this code is saying. Create a dichotomous variable that when child is 0, no child will be 1. And when their child is bigger than 0, when there is a child, no child will be 0. We'll get the frequency and we'll get the mean. So let's see. And you should remember this maybe early on in our frequency tables for number of children, and a few times you were asked a question about what percentage of people don't have any children. So in our no child variable, false, meaning no child is false, meaning these people actually do have children, you have 72.7%. And true, meaning yes, this group has no children, is coded, there are 27.3% of the people. The mean of this dichotomous variable is the same as the percentage or proportion who are true. So 0.2726 is the same as 27.3%. That is the share of people who have no children. Now you'll see that this is coded as false and true. You can also think of false as being a 0, meaning that that group does not have the property you're looking at, and that true is equal to 1. So let's interpret what we got. We created a dichotomous variable that is 0 if someone does have children, and 1, and let me clarify this, or false, and 1 or true if someone does not have children. We see that the mean of the no child variable is 0.2726, meaning that 27.3% of the GSS respondents have no children. Okay, I'm almost out of time on this, so I'm going to wrap this one up and return with the next step, which is making a bar chart.